Hello and welcome to Tonight a Date from the RSGB. Nowadays there's some impressive software and apps out there to help connect, coordinate and control ham radio rigs. But sometimes they don't quite do what you want for your particular station. But now there's a great free software tool called Node-RED, which allows you to create your own customized system. And tonight our guest presenter, Mike Richards, G4WNC, will show us how to get started. Welcome to Tonight a Date, Mike. Can you give us a quick preview of what you'll be talking about this evening?
Yes, sure, David. The idea this evening is I'll give you a very quick introduction to the background to Node-RED, but then I'm going to get scary and do some live programming. So I'm going to demonstrate a few simple applications so you can see how easy it is to do.
Oh, we look forward to that. We'll try our hands at programming later as well. So before your presentation, a reminder that if you're watching this at home on Monday, the 5th of June, then this is live. And you can ask questions and make comments on either BATC or YouTube chat at any time during the presentation or straight afterwards. Please include your first name and call sign, if you have one, within every message. And note that you can make this video stream fill your screen on most devices, usually by double-clicking on the picture or pressing the full screen button. But now back to Mike to find out more about Node-RED for radio amateurs.
Thanks, David, and welcome everyone, and thanks for inviting me along to speak on Node-RED. I started with Node-RED quite a few years ago, actually, because I just thought it had potential. But over the last year, I decided to get stuck into it, so to speak, and teach myself how to use it. And so what I'm doing today is sharing some of that knowledge that I've learned. Now, I'm not a professional programmer. The things I'm showing you tonight, I've learned the hard way by trying to do it. So it may not be the best way to do everything, but it works. And the programs that I'll demonstrate to you tonight will all be uploaded onto a site that I'll tell you about, where you can download them and adapt and play with them yourself. So let's look at what we're going to cover tonight. So I'm going to start off with the origins and development of Node-RED, because I think it's important to understand where it came from to see why it's the way it is. So we'll talk about what actually is Node-RED, because it's an odd name, tell you how to install it. We'll do some programming with Node-RED. And then the main part of this presentation, I'm going to build 3 separate projects and show you how to do them live. So you can see how easy it is to make programs with this visual programming language. So let's look at where it came from. So it originated in IBM's Emerging Technology Group, which are based, I believe, just outside Winchester. And the guys that led the way on this are Nick O'Leary and Dave Conway-Jones. And as far as I know, certainly Nick O'Leary is still very much with the project and offers support on the help groups and everything else. So he's grown with this and knows it inside out. And one of their roles in the Emerging Technology Group was to develop software prototypes for IBM. So a customer would come to IBM wanting to automate part of their factory, for example. In order to do that, they'd need to develop and knock together some software prototypes so they could demonstrate the capabilities and help sell the application. Now, of course, one of the problems with trying to do that sort of thing is that they have to handle data from a wide range of devices. So if you're automating a factory, you've got motor controllers to worry about, you've got heat sensors, humidity sensors, all manner of things you can imagine, and they will all be using different communication systems. So trying to pull all this together into a coordinated control system can be quite a challenge. So what the team end up doing is writing code blocks to interface to all the different communication systems that might be used with the various sensors, etc., that they encounter. Now, at the same time, that group, whenever the work is light, they're encouraged to experiment, which is quite forward-thinking of IBM. So they're encouraged to experiment with new technologies so that they're ahead of the game, basically. And at this time, they were experimenting with using JavaScript Node.js, which is sort of like JavaScript for use on servers, and JSON, which is a messaging system. And they were looking at using these to use a browser to connect code blocks together visually, which would simplify their role of pulling together prototypes. And they decided to use JSON, which is JavaScript object notation, which I'll explain in a minute, as a system to carry messages. Now, they used their code blocks to convert the messages from sensors and all the different things into this JSON message format. So here's an illustration of how that might work. So if you imagine this is a home system, home automation system I've drawn out here. So you can have temperature sensors around that place, which might be linked together with 2.4 gigs wireless systems. You might have humidity centers. The heat-in remote control might be on your Wi-Fi network as opposed to a bespoke 2.4 gig. Your hot water temperature control will probably be wired. Your boiler control will probably be wired. And to do home automation, somehow you need to get all the mixed messages from these devices into a common format so you can build a control system. So what the guys were working on was basically doing this. So between each item, there's a little bit of code that converts whatever the message is that they're sending into a JSON message. So the red part here is all a standard message format, which then makes it easy for one system to link to another system and to make the whole control system work. And it means if you want to add a new sensor into the system, all you have to do is write a little bit of code that converts whatever that sensor provides into a JSON message. So you can see the attraction of just having these little code blocks that do this. It's quite a neat way to make an automation system. So what's Node-RED? So it's what we call a visual programming language, and where you drag and drop functional blocks called nodes to build a flow diagram. And I'll show you this in a moment. Here's an example. So here's a simple application. If we want to control the frequency of our rig in the shack using Node-RED, we would need a numeric node so we can type in a frequency. We need another node that can talk to the rig and send that frequency to the rig. And then we will probably want another node that can read the frequency back from the rig to make sure it's changed. So that's a very simple Node-RED flow to control the frequency of your transceiver. So you can see it's a very simple process of putting blocks on a page and joining them together with wires, almost a bit like drawing a schematic diagram. So what does Node-RED actually do? Well, each block passes and processes messages, and they're JSON messages that go through them. And it takes action based on the content of those messages. And through this system, you can create applications with the very minimum of coding, as I'll show you in a moment. So at the heart of Node-RED is the use of this JSON messaging format. So let's take a look at it. It's a very special messaging format because unlike many messaging systems, it is a plain text message system. And the big advantage of a plain text message system is it's human readable. So you can look at the messages without having to decode them, and you can make sense of them. So let's look at a very simple message to show you how it's constructed. So each message starts with a curly bracket, and then you get a pair. The first part of the pair is whatever the data is going to be, and the second part is the data itself. So you describe the data and then supply the data. The comma means that there's more to come. So in the next field, the data is call, and the content is my call sign. A comma, so there's more to come. The rig is a Hermes Light 2, comma, more to come. Antenna, HF9V, there's no comma, which means we've finished this message. And so finally, it has a curly bracket to finish it off. Now that's a simple plain text JSON message. So as you can see, that's perfectly readable. If you just open that in a text editor, you could see what was going on. Now you can put any message in this. You can put all sorts of data. You can put tables in it. It's extremely flexible, and it's becoming the universal messaging system for use on a lot of web-based stuff, because you can see it's so simple to create, and you can make your own fields, and it's all self-explanatory. So it's a very clever system that sits at the heart of JSON, of Node-RED. So inside Node-RED, the default name for JSON message is just MSG, and we use a dot notation to access the bits. So in that last example, to get at the name, all we have to enter is MSG.name, and it would recall my name from that message. Similarly, if we entered MSG.call, it would retrieve my call from that message. So the simple dot notation technique enables to extract parts of a message quite easily, even from very long and complex messages, as I'll show you in some of the examples. So in Node-RED, the common term for a single item in a message, you'll see it's called payload. So msg.payload is the most common term that you'll see in as far as Node-RED messages go. So where are we with Node-RED now? So it's a mature open source project. It's been around for a few years now. It's at version 3. And now includes a dashboard. Now the dashboard is really useful because a dashboard is a graphic user interface where you can have all your buttons and dials that you use to control your interface. And that is really a game changer. When they brought out the dashboard for it, it really made it into a practical tool that people could use to build bespoke applications. It makes it ideal for amateur radio use. It's also mobile friendly, as I'll show you. These test applications that I'll build in a while, I'll be able to demonstrate to you. You can operate them directly on the phone as well as in a web browser. It's very versatile. And you can build entire projects in Node-RED. Let me just show you an example. So this is WO2X shack control system. Now the whole of the top part of this screen is written in Node-RED. So here you have control of a power amp, his tuner, the flex radio, and antenna switching, as well as all sorts of monitoring of voltages and lots and lots of things. The antenna rotator is particularly neat because this shaded portion indicates the direction of the antenna. And as you move the antenna around, that shaded portion moves around in real time. So you can see what's going on and how things are moving, etc. So you can see that's a really great interface. And that's downloadable from the internet. So you can use that. If you happen to have Flex Radio and Tuner Genius, Power Genius stuff, you can download that from the internet and adapt it a little bit and use it. But it just gives you an idea of the sort of applications that you can create. If you're a Flex Radio owner, there is very good support for Node-RED and Flex Radios. And there's lots of stuff ready available that you can download and use with your Flex Radio. So how do we install it? Well, Node-RED is completely free, open source, and it's available for Windows, Linux, and Mac. You get it from nodered.org. And a Raspberry Pi is a very popular option for playing with Node-RED because it's plenty powerful enough to run it. And it's good for experimenting because people are often nervous about experimenting on their main PC. So get that Raspberry Pi out of the drawer and use it instead. It's excellent for running Node-RED. And there is also a custom install script on the Node-RED site that makes it particularly easy to install Node-RED. So I thoroughly recommend using a Raspberry Pi for it. And I'll be doing that tonight in my example. So when we make an application in Node-RED, it's called a flow because we're basically drawing a flow chart, as you'll see. And we drag and drop code blocks, which are known as nodes, onto the flow chart, and we wire them together a bit like wiring a schematic, and I will demonstrate that shortly. So each node has its own configuration screen. So when you drag a node onto the flow, if you double click on it, a configuration screen will come up where you can change the way that node behaves. And most of these you can manage what they do without writing any code at all. And between all the nodes, it's JSON messages that flow. Now, two nodes that you ought to get yourself familiar with, and I highly recommend you do the tutorials on the Node-RED site. Their tutorials on Node-RED are excellent, and the first 2 or 3 tutorials really take you through these two very important nodes of the inject node and the debug node. Now, the inject node enables you to manually or automatically inject a message into your flow. Now, this is great when you're building up an application because it means you can just send a controlled message in and then monitor it through the system and make sure it actually works the way you want it to do, rather than use live data. So it's really useful for that. But it can also be used to do a regular poll of information. So for example, when we do a cat control example later, I use an inject node to update a meter reading every second. So it's a really useful node to get familiar with. The other one that's absolutely vital is the debug node. This is a node that can be wired into any point on the flow and displays the message content at that point. So it's really useful. If something's not working as you want, you can just connect this node to various points and it will show you exactly what's going on. And it's absolutely vital tool for troubleshooting. And as I'll demonstrate to you, it's also really useful when you're building a program because it helps you navigate to the particular message that you want to see. So in this example here, this is the layout that I'm using tonight. So I've got my Windows PC, happens to be Windows 11, but it doesn't matter. It can be any brand of Windows. It can be any web browser, to be honest. And it's accessing my Raspberry Pi, which has got Linux, the Bullseye version, and I'm also running FLRIG on it to access my rig here, which is an FT897. So that's how I'm set up here. But you can access Node-RED from anywhere on your local network. And if you open up the Pi, your router, if you open up the port on your Pi via your router, you can have access to it anywhere in the world. So the example applications I'm going to run through now is the first one is to control and read data from a Wi-Fi mains plugs. You've probably seen there's lots of these about. They've been popular with home automation, and it's simply a mains plug. It plugs into a standard socket and puts a socket on the other side, and you can control it via Wi-Fi. Now, a lot of these plugs, in addition to being switched on and off, also supply a whole load of extra information, such as the voltage, the current consumption, the power consumption, etc. So we're going to cover one of those. I'm also going to control a Wi-Fi connected relay board. Now, relay boards are very useful when you want to control items in a shack. Perhaps you want to do antenna switching. You don't want to do that directly with a Raspberry Pi. So having a relay board that's Wi-Fi connected gives a nice way of keeping the RF under control and controlling all manner of things. And finally, I'm going to show you how to do some remote control of a rig and take readings like S-meter readings back from the rig. So that's enough chatter. Now it's into playing. So I'm just going to jump out of this and get back to Node-RED. So here we are. This is Node-RED. This is what it looks like when you log into your Pi or whatever. You've got this main screen with a grid on it, which is let me just move this a minute. Which is where you draw your flow. And down the side here, the left-hand side, are all the nodes that are available to you. And there's lots and lots of them there. They all come as standard. So there's a huge number of nodes available. And all you do is drag these on to make your flow. So we're going to start off by building a main plug controller. So in order to do that, we need a node that's not already here. So we need to install a node, and that's really easy to do. You go up to the right-hand side here, click it's called a hamburger menu because it's 3 horizontal lines. And you go down to Manage Palette, and this screen comes up. And if you choose Install, and I'm going to choose TP-Link, which is the manufacturer of the nodes. Now you see there's several TP-Link nodes here, but the one we want is this one called Node-RED Contrib TP-Link. And if I click Install, that will just very quickly install. Once it's installed, there we go. It says there that it's added it to the palette, so we can close this. So if we look down the left-hand side here, we should find that it's appeared. And yes, it has down there. So that's the block we want. So we've dragged it onto the palette. So now what do we do? Well, let's open it up by double-clicking on it. And we get this screen come up, which is its properties. Now we need to give it a name. So we'll just call it a mains plug. And here, the device IP, we need to put in the IP address of the plug so we know where to find it. Now, when you set up these plugs initially, you have to connect them to your own Wi-Fi system. So if you follow the manufacturers to do that, to install the plug, you should, as part of that process, make a note of the IP address. It's also worth going to your router and giving that IP address a permanent lease, because then it won't change. So you don't want it to change because that just confuses things. So my IP address for this plug is 192.168.1.158. And down here, we've got a chance here to say what we want this plug to get, this node to get from the plug. So every time it's operated, we can ask it to get some info. And this little drop down says what we can get. Now, the best one for this plug, I happen to know, is get quick info. So if we hit done, we've now configured that node. And you'll see it's got a little blue dot just above it on the right. That means it hasn't been deployed yet. So we've made all the changes on this screen, but it's not been implemented. So we have to go up to the top here and hit deploy. There. Now, once you do that, it's then working and is available. And you'll notice there, if I just zoom in a bit, I'll get it clearer. So you can see now that we've got a message underneath this plug, which says one device connected, it's switched on, there's 0 watts being used, the mains voltage is 247.2, and there's 14 milliamps being consumed. So that's the message that the plug is getting, was part of the message that the plug is getting back, which is really useful for us. So let's go back out again to our normal size. So we really want to do more than just have the mains plug connect up like that. We want to be able to turn it on and off. So how can we do that? We need to send a message to it. So if we get an inject node and wire it up like so, double click on it. So we'll call plug on. That's what we want it to be called. What we want to send to the plug to turn it on. Well, the method we need to use for this device is it's true or false to turn the plug on or off. Okay, so we can delete this other message. We only want the one. So we choose here Boolean, and for the value we choose true. So deploy that, and now every time I click that, it will turn the plug on. So now we want another one, don't we? Because we want to be able to turn it off. So if I copy that node and paste it, wire it up, and double click on it, and I want this one to be false, and I want the name to be off. So if I zoom in again, and you look carefully at the message that's coming up here, you'll see that I'll deploy it, otherwise nothing will happen. So the plug is on at the moment. If I click that one, it will go plug off, plug on, plug off. So you see we've got a simple, we can turn that plug on and off now, which is great. But being able to turn it on and off by pressing this button is not terribly imaginative. And what we really want is it to be on a web dashboard somewhere so we can turn it on and off. So what we need now is the dashboard. So again, we go up to the top here, manage palette, install, and there's thousands of palettes here, by the way, that you can choose from. So we want Node-RED dashboard, and it's the plain one that just says Node-RED dashboard. And you'll see it's bang up to date. This one was only released a week ago. And you click install, and it's going to store a lot of nodes. All that lot has been added, which is great. So now if we look down the left-hand, if we close that, if we look down the left-hand side here, in amongst all of this, somewhere near the bottom, there we are, we've got the dashboard, and we've got a button we can use. So if I drag that button over, and I'll delete these because we don't want these anymore, get a button connected to the mains plug, double click on it. Now, one of the things we have to do when we start adding items to the dashboard is we have to have a group to assign them to. So you'll get this come up first time. So you need to click on that, and we'll call this mains plug. And we'll also add a new tab, and we'll call that KASA. We click add, and add there. Now we get to be able to configure the mains plug. We want the label to be power on. And in the payload, remember payload is where we send our basic message, we want it again to be Boolean and true. And there we go. So that's on. So now what we want to do is copy that and paste it, because we want to be able to turn it off again as well. So we wire that onto there, double click on this to edit it. We've already got our group assigned, so that's easy. So this one's power off. And of course, the message we want to send is false to turn the plug off. We deploy that. Now, we've got a user interface for this. So if we look over here, this is another web browser that I've got up, which has got the two buttons that we've just created. So if you watch this little message over here, when I click power on, that goes on. When I click power off, that goes off. And the great thing about this is that it's mobile friendly. And so if I hold my phone up, give you a minute to catch that, you can see that I've got the buttons there, power on, power off. and I can control it from my mobile phone at the same time as I can control it from the computer. Now, it's not a very classy layout at the moment, but it works, and we've got control of this plug. So let's minimize that. So what else could we do to this? Well, it would be quite nice if we use the information coming back from the plug to perhaps have a meter. So maybe we could show the mains voltage. So if we look over here, we can add a gauge. So we wire a gauge in, and if we double click on the gauge, we can configure it. So it's in the right group. It's called a gauge. The label is, let's call it mains voltage. And now the value, we don't know where in the message we can find the mains voltage. So we can't do that for now. What we do know is that it needs to be in the units are going to be volts. Oops. And we know it's going to be in the range, say, 0 to 260 volts. So for the moment, we can save that, but somehow we need to know where to find the mains voltage in the message that comes out of the mains plug. So how do we do that? We do that with the debug node, and it's absolutely phenomenal for doing this. It makes it so easy. Okay, so we just drag a debug node in, wire it into where we want to monitor. So every time we operate the plug at the moment, a message is going to come back, which the debug node will pick up and show over here. So if I hit deploy, and then I go to our little graphic interface, and if I just turn the power on, we get this message over here. Now, this looks like gobbledygook, which it is initially, but if you click on this little arrow, it breaks it down into all the various components of the message, because it's quite a sophisticated message that's coming back. If you go into e-meter and then into real time, we can see, there's the voltage. Now, the absolute gem that's hidden in the debug node that people often miss is if you then go over to the right here, it says copy path. And what that does, it copies the path to that message. So you just hit copy path. And if we go back to our gauge, we now know that if we paste that in there and put just MSG dot at the front and deploy that, we will get the mains voltage on our interface. So if I bring up the interface again, there we are. Our mains plug, our little monitor has now got a mains voltage. Now there's one problem, it's not showing any voltage. So why is that? Well, it's because you only get a reading when you operate the plug. So when I click power on, we'll get a reading. When I click power off, we'll get another reading. So we could do with it updating regularly, really. So how can we do that? A simple way to do that is with the inject node. So if we get the inject node, we want to send a message in to the plug at regular intervals saying, please, can you tell me what's going on? So there we go. So this is the message inside the inject node. We don't need the second message. We only need one. We don't want a timestamp. We need to send a string with the command, which is get quick info. Click done. And now what we want to do, the other thing we can do with the debug node, with the inject node, is we can set it to repeat. So we could say repeat an interval of every second. So what will happen now when I've deployed that is it will now probe the plug every second for an update. So you'll see now that the mains voltage is changing every second. Now, this plug happens to have a pretty ridiculous readout. I'm sure it's not reading the mains voltage accurate to 6 decimal places, although it provides that as the information. So really, for our purposes, it would be better if that was limited to, say, just 1 decimal places. So how can we do that? Well, we can do that quite easy with the tiniest bit of JavaScript added here. And you simply write .to fixed, and in brackets 1 for the number of decimal places you want. Done. Click deploy, and if we go back, now we're getting the mains voltage with just 1 decimal place. So that's looking pretty useful to me, and is a good starter for controlling that mains plug. Now we can obviously use the same principle, which I won't labor now, but we can use the same principle to tease out all the messages that are available for that. So we can have the current being measured, and the power consumption, and the whole works, everything that's available. But the technique I've just showed you is the way to get at those messages quickly and easily using the debug node. And of course, once you've finished with it, you just hit delete, deploy again, and that's gone. So there's a simple way to control a mains plug with a nice little user interface that you can operate from anywhere in your shack or anywhere in the world if you open a port on your router. So that could be useful for all sorts of things. If you've got a remote station, it could be a very useful kill switch, but lots of applications I'm sure you can imagine what it could be used for. So now I'm going to stop zooming for a while and get back to normal. So what we really want to do is let's dump this flow and start again with a different one. Let's clear that flow. Whoops, that flow. Go there, flows, delete. That gets rid of the old flow, and we'll clear out the dashboard. Edit that, and we'll delete it. Okay, so let's do something else. Now this time, what I'm going to do is I'm going to control this little relay board. I just hold that up for you for a moment so you can see it. So this is a wonderful little relay board from Robot Electronics in the UK. It's really nicely made. This one has got 2 relays. I think you can have up to 8 or 16 relays. It's got screw connections for making connections to the relay. They're all rated at 240 volts and full current. And it's just a really nice little device. It's Wi-Fi connected. You just need to add a 12-volt power supply and you're in business. So I highly recommend them. I've been very pleased with that. The other nice thing about this particular relay is the amount of information available from it is excellent, and there are 3 different ways of controlling it. So for tonight, I'm going to control it via HTTP. So let me just get to my right cheat sheet so I don't make mistakes. So the first thing we need to do is we need to get a node which does an HTTP connection. So we want an HTTP request node. Okay. Now, a bit like the mains plug, it's got an input and an output because you send messages into it, but it also replies with messages that we can use. So the first thing we need to do is configure this node. So as before, double click on it and we get the configuration screen come up. Now the default method is called get, which is exactly what we want. And where do we want to send the request? We want to send the request to the relay board. And when you connect the relay board to your Wi-Fi system, again, you need to make note of its IP address. So in this one, we've got 192.168, the usual stuff, 1, and mine's 112. Now, a little trick we do here, which is quite useful. When you're making an HTTP request, it's normally all done on one line. And in order to get Node-RED to do it all on one line, you have to add 3 curly braces. So we just do 3 curly braces, and then we write payload and 3 more curly braces. And what that does is whatever we put in the message payload will appear at the end of the URL request when it's sent. And below that, we leave the payload to ignore because we don't want it to do anything else with it. And down here, just make sure that it returns a UTF-8 string. We don't need to add any headers or anything complicated. So that's that done. So that's now deployed. So now, every time you move anything in this, you have to deploy it again before it takes effect. So now we want to turn that relay on. So what do? Let's go straight to the dashboard. And we want a button. And this button, we want it to send a specific message into the payload. Okay, so we need to get rid of that. We'll call this relay. And we'll have a new one there, which will be robot. Okay. Now here, we're going to call this relay 1 on. And we don't need a tooltip, but the payload, we want it to send in the command, which is query RLY1 equals 1. Now you get that from the instructions for the relay board, but that causes relay 1 to switch on. And if you send relay 1 0, it causes it to switch off. So we do that and we join those, join those 2 together. So if we now copy this, and we'll do a few more. So if we paste and paste and paste. So the next one is going to be relay 1 off. And so relay 1 there will be 0. That's done, and we wire that to there. And this one will be relay 2. So relay 2 on. So the message there changes to relay 2 1. And this one is going to be relay 2 off. Make that off. And relay 2 0. Okay, so now we deploy that. And if we go and look at our interface, here we are, we've got a brand new interface being created where we can turn the relays on and off. Now at the moment, we haven't got any indication as to whether it was really turned on or off. And one of the problems is if you were using this to say, you might be sequencing the changeover of antennas at a remote station, you would want to know that one relay action is completed before another one starts. So it would be really nice if we could have a message back from the relay board that says, okay, I've done that action, etc. So what we can do here is if we use the debug node again and connect it to the output, we can see what we get in terms of messages. So if we go up here to the debug bit. So if I now open up the little front end, we should see a message appear on the right here whenever I click one of these plugs. There we go, there's a message. So now we need to look at that message, and we've got the little arrow, but there's no more little arrows. So it's not very easy to get down through this and find what we want. So that's a bit of a problem because it's not a JSON message, but there's an easy solution. As you might imagine, there's an easy solution because Node-RED comes with a load of nodes called parsers. And what the parser does, it converts from one message type to another, because clearly they're expecting messages to come in all sorts of different formats. So if we put the XML node in there, delete that and connect an XML node like so, and then to the debug node, this is going to convert that XML message into a JSON message. Hit deploy. And if we now click on that plug, we'll get a new message here. But the difference now is we've got these little arrows. We can open this up and go all the way down. And you can see we've got our status there for relay 1 on, relay 2 off, etc. So it reports the status every time. So what we want to be able to do is to extract this message and display it on the desktop. So if we go to the dashboard and we grab our text, which has disappeared. I had this earlier, which was frustrating. It's to do with the zoom in, I think, that screws it up. There should be a text node here and it's not appearing. No. No. Okay. What I'm going to do, I'm just going to quickly uninstall manage palette. Node-RED dashboard. Oh, it's in use. I can't uninstall it. I tell you what I'm going to do for the sake of wasting time at the moment, because things always go wrong when you're doing a live demo. I'm going to drop this flow entirely. I'm going to flows, delete, and I'm going to import a flow from, because I've got one I prepared earlier. Just
I was just going to say that, Mike, that it's well-worn cliche of here's one I did earlier, and underneath the desk you bring one up. This is just while you do that, I know that's going to just take a moment and to stop taking to take a little bit of focus off you. I just remind everybody that's joined us since we started, if you've got any questions or comments or anything like that for Mike, or maybe you've used Node-RED or something similar for your amateur radio projects, then don't forget to put them either on YouTube chat or BATC. But as you can see, this is a very live demo if you're watching this on Monday the 5th of June. And Mike is now just rebuilding his desktop there to give us this demonstration. But do put any comments in or anything like that that you've used to control your own radio station using something like Node-RED. Anyway, back to you, Mike.
Okay, thank you. Yeah, so here we are. This is what I prepared earlier. So we've got our relay on and off buttons, and we've got this XML to JSON node in place, and then we put this text box up like so, which we're going to use to display the status of relay 1. And the whole of this lump in here of gobbledygook you get by clicking on here and choosing the message you want, so copy path, and then you paste it into this field and it puts the route to that particular message in place. So now that we've done that, you'll see that our little interface now is much more sophisticated. So now when we press a button, we get the status of the relays that changes as I click these things. Now, the beauty of this system is that the message you're getting back from the board tells you when you've completed the action, which of course is important for certain applications if you're sequencing changeovers, etc. So it's one of the nice things about this relay board, and the way you control it with Node-RED, you can get these messages, and you could use these messages to trigger other things if you wanted to. So that's the relay board. So the next thing we want to do is to move on from there, and we'll just finally do the cat control. And what let me just clear the flow. Whoops. That flow, we'll get rid of that out the way. That's it. Good. And now, in order to do the cat control, I'm going to be using FLRIG, which is a popular rig control software. That's running on a Raspberry Pi sat here next to me, and it's connected to my Yaesu FT897. So just by way of a simple example of how to do this, the FLRIG software can control a huge number of rigs. So this same application will work with all manner of rigs, providing you select the right one in FLRIG, wherever you're running it. So in order to do this, we need to be able to talk to FLRIG. Now, FLRIG, the easiest way to contact it is to use a protocol called XML RPC. And that node is not included with Node-RED, so we have to go and find it. So we go to Manage Palette, Install, and then search for XML RPC. And there we go. The first one on the list is the one you want. It's quite old, but it's absolutely fine and works a treat. And we install it. There it is, that's all installed. So the next thing we need to do is to configure that. So we get the XML RPC client, which is appeared down here somewhere. It's funny how you go blind when you're doing this sort of thing, don't you? There it is. No, XML. Nearly. It's a bit spread out, this one. It's not the easiest thing to find. XML RPC. I bet you're all screaming at me. There it is. There it is. There it is. Cool. XML RPC call. So we double click on this. We need to configure it. So we need to add a new client, and this will be FT897. And so we need a location for it, and the location is I'm having a blank, so I'm going to load one. Just a moment. Okay, so I'm going to import a flow. It's dead easy to import flows, by the way. And this is how you do it. If you've got the code somewhere, there's my code. Open it in a text editor. That's not the one. I know what I'll do. I'll show you it from the web. Okay, so this is actually be useful. If we want to include a flow that's available on the web, and there are lots available on the web, you go to the Node-RED website, flows, and there's something like 4,000 odd nodes, flows available. If you search for G4WNC, you'll find already up there is the flow that I've created for tonight that I was going to show you. So all you do is copy that onto your clipboard, and then you go back to Node-RED, choose import, paste it in, paste as plain text, import, and there we have it. And then hit deploy, and it's all there. So let's explain what we've got. We start with this first one here, set VFO. This is an XML RPC call node, and it's going to the Raspberry Pi where FLRIG is running, and that's the port. And it's going to use the command rig set VFO. Now, all these commands are listed in FLRIG in the help file, but this will set the VFO. And all I do here is enter a number. Now, FLRIG wants the frequency in hertz, which is a bit cumbersome to type in. So what I've done, I've put a conversion node in here, which will convert kilohertz to hertz. So on the front panel, I'm just going to have it say enter frequency in kilohertz, and you just enter a number. This one converts the range from 1,000 kilohertz to 30,000 kilohertz, i.e. 1 to 30 megs, into 1 million hertz to 30 million hertz. The 0.1 is necessary because there's a glitch. I'm not sure whether it's in the XML RPC or in FLRIG, but it needs that, otherwise it won't take it. And that enables us to set the VFO. So if we look at our web interface now, we've got a completely new web interface has appeared. It came with that. And in here, I can enter the frequency in kilohertz, and it will change with the rig. So that works very nicely. The current frequency is coming from down here where I'm polling the rig to ask it what the current tune frequency is. So that's providing a confirmation. So if I go here and write 21074, for example, hit return, you can see then it changes, which is confirmation that the rig's actually changed. So that confirmation is useful for when you're doing any remote control. Now, the other things that I've got here are quite interesting in that I've got a signal meter and I've got a log of the S meter, and they're just really easy to do because this node is just sending the command rig get VFO, and then it displays it on a on the frequency display. And down here, I'm asking it to rig get dBm, and it shows that on a signal meter, but it also shows it on a chart. And the chart, you can vary the range of the chart, you can vary the time period of the chart to whatever you want, and label it however you like. So it's really quite a simple application. I haven't had to write any code at all, and we've now got a rig control system, a basic rig control system that you could actually use from anywhere in the world to control your rig. If you are thinking of doing this from anywhere in the world, you do need to read on the Node-RED site about the security precautions you need to take, and also make sure the password on your Pi has been changed. Okay, so I think at that, having got you and me thoroughly in a muddle with things that didn't work, as I guess they were bound to at some point, I think it's probably time to go back and ask for a few questions.
All right, Mike. Well, very well done for that. It was brave. They say never work with animals and children on television, but maybe also live software demonstrations. But no, but it does show you it's very real, and I think it also showed how you can recover from that as well. We would now encourage everybody watching at home to ask any questions if you haven't already done so. We haven't actually got any questions for you yet, so I do hope that some of you at home have got some questions for Mike on how to use this. And as I said earlier, if you've got any demonstrations or anything like this that you've ever used Node-RED or anything similar for, because Mike I know is into lots of coding and lots of applications and things with Raspberry Pi, then please enter them now onto YouTube chat or BATC. Can I just start by asking you, Mike, if you, like you get started programming this and then you end up with something, you mentioned there was a 0.1 which you needed to add to get over a glitch. Well, most of us have done any kind of programming or any kind of indeed any kind of work with anything, microprocessors or whatever, you tend to look on forums for answers where there's lots of other people who will experience similar. Are there good forums for Node-RED?
Yeah, it's very well supported actually. The Node-RED forum itself on the Node-RED main website is excellent, but there also is a Groups.io Node-RED amateur radio group, which is absolutely packed with flows that you can download, lots of expertise. They've been doing it longer than I have, and you can always get help there. So that's a really good support site. I also ought to mention that all the flows that I've shown tonight will be available on the Node-RED site. If you just search for G4WNC, you'll see all the flows listed, so you can download and play with them if you like.
Yeah, I was actually going to ask you where you got that from earlier, the one that you'd already entered, and you searched for your call sign. So that was actually a Node-RED website, is that right?
It is. It's the main Node-RED website where people share their flows. And there's about 4,500 flows on there at the moment. So people are very generous at sharing their flows. So all the ones I've used tonight will be up there and available by tomorrow.
And I guess we should mention that Node-RED isn't just used for amateur radio, but I guess it's used for all sorts of things. Can you give us any examples of what it's used for?
It's used extensively for home automation. It's absolutely brilliant for home automation. People who want to do their own home automation projects, it's absolutely ideal for that. But really anything where you want to control a range of different devices and you've got messages flying around giving you temperatures, whatever, any information. It's such a simple way of handling those messages and producing a very quick web interface that makes it easy to control and view data, because you can also scrape data off the web with this very easily. So if you wanted to produce a screen that connected sunspot data, activity of various modes, it's relatively easy to scrape that off of the web and display it in Node-RED.
Yeah, I mean, my local radio club here in Norfolk, we've recently just started doing monthly sessions on learning about the Raspberry Pi, and we've just started now programming in Python. And one of the things that strikes me, and I'm in that class as well, and one of the things though that strikes me is it's about syntax and everything. You have to get it just right. If you don't get everything right, even sometimes case, and we're used to now in many programming environments not having to worry about case, whether uppercase or lowercase, but this you do. It strikes me that Node-RED's a really good tool in that way, in that it's mainly visual and it's mainly sort of click. Is that a fair way to sum it?
Yeah, I think it is. You can add JavaScript to various scripts to do something very specialist and dedicated. But as you've seen from most of the nodes that I've used, you click on the configuration box and all the available options are there, and you just choose the ones you want. All that was the only bit of code I used in the whole of all those applications was where on the mains voltage, I just added that to fixed to limit the decimal places to 1 decimal place. That's the only JavaScript I used in the whole application.
Yeah, so that's the only thing we're typing, and a little bit of knowledge there. And I guess, again, you'd find this sort of information on the forum if it's to fix a common glitch.
That's where I got it. That's where I found out how to do that, to trim the number of decimal places.
You know, I know you're a great fan of the Raspberry Pi yourself, and you've been using the Raspberry Pi to actually run the code tonight, even though you've connected it to your PC to show us how to program it. So I presume once you've written a script for Node-RED, or you can leave it on the Raspberry Pi, and you could leave the Raspberry Pi dedicated to running that application.
You can, yeah. You can run it anywhere, to be honest. There's no conversion needed if you want to run it on a Raspberry Pi or a Windows PC or a Mac or a Linux setup. But once you've got it on your local network, it's available to any computer on the network.
Yes, lovely. So you don't have to tie up your PC or your Mac or whatever to doing an application.
No. It's very lightweight as well in terms of processor usage, because most of the time it's not doing very much. All it's doing is passing messages around.
Yeah, well, it does seem a really good use for it. And if I might, at this moment, it's a good time to mention a book that you've written a little while ago for the RSGB about the Raspberry Pi Explained. I think we've got a copy, have a look at it there, which you can get from the RSGB shop. And this is a really good use, isn't it, for the Raspberry Pi as well?
Oh, yes, excellent. Because I know there's a lot of Raspberry Pis sat in top drawers that have been played with and put away. This is a very good application for a Raspberry Pi. This works perfectly well with Raspberry Pi 3 and above. I haven't tried it on a 2 or an earlier one, but the loading is very, very light. So it's perfectly happy doing this.
Yeah. Well, it's been a brilliant introduction tonight on this. I mean, you've given us a flavour of how to. Finally, if you want to learn more about it, as well as watching this webinar, where would you suggest people go to find out, how to take the programming to a slightly higher level?
Well, the first step should be the Node-RED website, because on there they have got some excellent tutorials that go into quite a lot of depth. They're very well paced tutorials because they're designed for beginners, so they don't assume prior programming knowledge. So they're excellent, but also the Groups.io Node-RED amateur radio group have also got tutorials that they've posted on Node-RED that you can get to. I think they're on YouTube, but you can get to them via the Groups.io site. And that's another good way to get amateur radio specific stuff.
Lovely. Well, it's a really good way. Has some lots of lovely comments for you as well. James Knox says Node-RED appears similar to GNU Radio Companion for SDR development, which is good. So some familiarity there, maybe if you're working on both platforms. Dave Odessa says, I've seen some makers use Node-RED, but never had it so well explained as in your presentation, Mike.
Oh, jolly good. Thank you.
And also Tim GW4VXE says, that was excellent, Mike. I've got ideas to try out now. So many thanks. Thanks for those comments. Thank you very much to you as well, Mike. And thanks for coming to join us again on Tonight at 8.
Yeah, well, my contact details are widely available. So if anyone needs help, just get hold of me. And all these flows will be available very soon on the Node-RED website.
Just look for G4WNC.
Yeah, search for that. I always put that in the title, so they're easy to find.
Lovely. All right. Well, many thanks again, Mike.
No problem.
Thank you.
My pleasure.
There we are. And that concludes this webinar. And thanks once again to our guest presenter, Mike Richards, G4WNC. And also thanks to the team who helped put this series together behind the scenes. Well, we hope you've enjoyed this Tonight today and that you'll be able to join us next time when Eric Nichols, KL7AJ, will tell us why receiving antennas are different. Now, if you'd like to see details of future webinars or watch recordings of previous programs in the series, please visit rsgb.org/webinars, where you can also send us comments and feedback. If you subscribe to the RSGB's YouTube channel, you'll also be notified of all upcoming Tonight at 8 webinars, as well as other new videos and presentations from the Society on a wide range of amateur radio topics. And if you're an RSGB member, do sign up for our emails about online activities, as well as receiving information about upcoming events. You'll be invited to share your suggestions for topics and speakers and help guide our plans for new events just for the RSGB members. To sign up for this new service, head over to the RSGB members portal, rsgb.org/members, and tick the online events option in the preferences section. Until next time, this is David G7ERP signing off and clear. Bye-bye.